Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.
How do? Welcome to The Meaning of Life 42. Yeah. Anyway, let's just get on with it. So hopefully this is the last one for physical thing, apart from the software. Let me just check audio. Let's see if we've got some audio. Give me a second. Let's just get on with it. Yeah, we've got some audio. What an intro, lol. How you doing? Welcome, Thomas. Let me just welcome you in. Try and welcome everyone in. Thanks for joining in. So, yeah, I wanted to do a little bit refining, and hopefully it won't take too long tonight, hopefully, and just want to beef up the contact holder a little bit. And I've got an announcement for the next project that'll run slightly parallel because it's almost similar. Now this is going to be good, I think. Anyway, what did I do last time? I'm not sure if I did anything. Can't remember. So we've got a few of these things going on. There's one that needs a slight upgrade. We've got this one that was working nicely. On a stepper motor, and we've got that one that we made bigger, which we're not going to use. We're going to use that one. Anyway, so there's that. Now let's have a look at the thumbnail. So yeah, some tweaks. So we want a few tweaks, so let's just get back on with it. Now, do I announce what we're going to be working on next? I think so. Anyway, because we've got a stepper motor, we've got our stepper motor already turning. So what I propose to do, I've seen the price of rotators. They're not cheap. So anyway, we've got a bearing that we use. We're on my day job. They use a bearing. It's designed to stand a hinge of a gate on, so it's around like that, and the bearing sits on, and you weld your gate onto it. So if I weld a slightly bigger than a 50mm diameter ring on the bottom, we can slide in a scaffold pole or aluminium onto it. Now that'll hold it onto the floor. Anyway, this is going a bit mad. So imagine if you've got, let me just bring this one up away. We'll have a look. We'll use this. This is not the idea. Imagine this is a scaffold pole. Now that end sits in this thing that sits on the floor or bolted to the back, and that gives you the spinning capability. Then further up, you have your brick clamp against the wall. So your standard aerial type of thing with the two poles. Now the top bit has a bearing that goes across. Now that you either have to slide your bearing on from the outset, and you slide it up, and then you bolt it onto the pins that go across like that. So that holds it, and that gives you your bearing allows it to rotate down the bottom and holds it in place at the top. So then what we're going to do is design a two-part thing, I think a two-part, that grabs the shaft here. So you got your, I forget what they call it, your T, it's like a, you know, you got your standard antenna mount that fastens onto a wall. Then you got your bar at the top, bar at the bottom. So the bar at the top will grab the antenna and hold it this way. The bar at the bottom will hold your stepper motor and your pulley wheel that fits around. I'm going to 3D print a two-part pulley wheel so you can fasten it on. You screw it either side and it holds it on, and the top piece marries up with the teeth, the same as a pulley, the belt pulley. Now the diameter will be bigger and it'll be geared down to a small wheel, so big wheel to small, and we'll spin the stepper motor fast. It doesn't have to rotate quickly, so it'll grab this and the belt will just spin it round slowly like that, right? So spin it round, so you can't see it, so spin it round, and then you can alter the direction. So basically you've got a bearing at the bottom, a bearing at the top. The bottom must be bolted, probably have to be bolted up to either the floor or a wall, and then the other bit goes, I mean possibly yes, you could bolt both. So I don't know how to explain it. I've got some downstairs, but just normal brackets for wall mounting, so you can mount your, so you can have one lower and one higher. It holds in place, and you bolt assist one of these boxes on the side of the pole that contains all your stuff, and then we've got to make the arm and that. Anyway, that's another project. So I've seen the price of stepper rotators, antenna rotators. So we could make a small one out of tube, aluminium tube. Then you can just, you know, you can make it a few foot, I don't know, 3 or 4 foot, 5 foot, whatever you want, and then put your aerial on top. And it's a lightweight thing. Now, because it's running on bearings, the bearings take all the weight, so you can just spin it round. And the stepper motor, the belt, and the big pulley wheel will allow for the gearing, and then we can just work out the steps to change direction. So from the same web interface as we're going to use for the stepper motor driven antenna switcher, the same interface will just say mode of operation is either antenna switcher, mode of operation is rotator. So then we can use the same app. You can just log into the same app. Well, it's not even an app, it's hosting its own web interface. The firmware is running its own web interface. So you can have your rotator on the screen, another browser, or off your phone or off your main computer, another browser doing your rotator. So you can then introduce sweep onto it and all sorts of stuff. Yeah, and if you use it with a cat control, and if you can measure your radio, bring back its signal strength, and you should be able to align it to the best strength. It's difficult with sideband, but you might be able to do something with it. Anyway, the aerial you put on it is entirely up to you. Anyway, that's my next project by the sound of it. But it runs parallel with this one because it's using the same technology, same stepper motor, and the same web interface. So there you go. That's the next one. Anyway, let's get back to today's one and carry on with this one. So yeah, I wanted to do a few changes, not much, just to make things a bit stronger. Right, so we sorted out the backlash on the last one. That's fine. Now, let me just get rid of a few things. Oh, hang on. It's all connectors, right. So, I made this interchangeable holder for the contact. It's okay, but it prints out a little small. It's actually smaller in real life than it is. Let's have a look. Oh, that's not one. I can't get one when I want one. So it's only this small. So look how small it is. So, and it could be if it does get locked in, it could snap. So what I'm going to do is put some more meat on this, and with the idea of it's more interchangeable. So anyway, we'll get on with that. And it doesn't matter if I've printed a few of those out; they're only tiny bits of plastic. So anyway, so and I thought about because we want the earth strap or the common strap to wind around here. You can't see it at the minute. So as you turn this, it wants to wind around this space. So I thought this, instead of this being angled here like this, it would be better if we had a conical shape. So we need more meat on this one, more wider on this one. That can be easily done. More plastic, because that's quite thin to, you know, it could break off or something. So we won't need to do that. And yeah, so and then make this conical. So when anything wraps around it, the cone automatically pushes the strap towards the centre. It guides it to where we want it. So this gap between there and there is what wraps the earth strap around as you turn it. It undoes it and tightens around it. So that's all we need to do, and everything else is the same. So to that effect, let's just get rid of a few things. Anyway, that's that. And also what I wanted to do as well, if I get time, I don't want to work too many hours, I've got to have me tea yet, but you can see what we've got the lid here. If I could just bring that in the centre. So we've got the lid, and I thought, I know I've already printed out all of those there. I've got a load of these just blank ones with nothing on them. So I don't mind having some blank ones anyway. What I wanted to do is create another plate here. So another plate here. We could do that now. Basically just go on to add a plate. So we've got a new plate, and we'll import. I'm not going to do it now, but I'm just going to get it ready on there so we've got an idea. So this is going to be the bottom piece, but it's the same as the top actually. Lid and base. No, that's not it. Where did I put it? Lid and base STL. Is that the latest one? Not sure if that's the latest one. Let's have a look. 25th of the 2nd. Probably is the latest one. Switch your lid and base. Let's have a quick look. That's it. Let's see if it is the right one. Yeah, it certainly looks like the right one, doesn't it? Yeah. So we'll start off with that, and that'll be the base. So the graphics and all the stuff that we took off the cluttered view of this one's got the cluttered. So we want, it'd be nice to get a QR code on the back to take you to the website for maintenance instructions and whatever else, setup guide if you're making your own, with some of this detail that I put in black on the back. So we end up with that there, I did want to raise that up slightly. I think I'll leave that alone since I've already made it. So on the back we got some graphics and stuff. Now you're gonna, once you've got it on your stepper motor, you're not going to see it anyway. So you're just going to see that. So I'm not bothered about that. But at least if you're using it in option 1, so option 1 is manually, like that, manually. Option 2 is with a stepper motor add-on, and option 3 is in a weatherproof enclosure. I haven't seen that in the weatherproof enclosure. So that will be stuck in there like that. In there like that with the switch in place with the lid on. And there's also room in there for the controller. If you want to put it directly in there, you can. The controller has got enough room in there, or if you want to put it in a separate weatherproof box with a lid, you can do that. You've got your gland holes at the bottom and your water drain holes, so that can be mounted somewhere else. Your stepper motor, normally you've got maximum 2 meters between your controller and your actual stepper motor. Anyway, there's that. Right, so let's start off with, I just want to get on with adjusting this. I could have just done it offline, but I thought I might as well stream it anyway. So the first thing we want to do is make this wider. And also I noticed that I'd got a gap here. For some reason I'd got a gap. Now, I think the gap was due to the solder on there. No, I don't think so though. Hang on. Yeah, not sure why I was getting a gap. So when I push together, it's okay. It's just not enough. Not quite enough. So I'll tell you what we want to do. That needs to be the same height. Exactly. Now what I want to do, keep this back bit down, maybe make this sides bigger and have that smaller, just to make it easier to assemble and make it click in place better. So I think we'll start by turning it over the other way around. We're going to go at it upside down. I need to lose some of the stuff so we're not looking at everything at once. So we'll leave the bottom off. We'll leave the sleeve off, the ball bearings, if I can find the ball bearings again. Right, hang on, modular center. Right, so we don't want the holder contact. No, we want the contact holder and the feed. What's that one? No, yeah, we want that. We don't want the spacer. Now that spacer, I need to look at that as well, because I did break one the other day. Now, I don't know why it broke, but it might have been one that I printed without enough walls on it. So I might print them with 4 walls, make sure it's 100%. And if we can alter it a little bit, it would be nice, but if not, right, so I might be able to make it a bit thicker. I don't know, we'll have a look at that. So I need to get some of this stuff out of the way, so let me see what this is. So that is the spindle contact holder. That's just not, is it? That's not the contact holder, that is actually the top, the actuator. So look, yeah, that is not the contact holder at all. Right, so if I say that it's that, which it isn't, right. So I need to create a new one there. Have I got one down here? SM bottom. What's the SM bottom? No, that's it. So I haven't got a top. So cover, contact cover. No, that's that bit. Right, let's create a new one. Modular. Spindle. And it's the knob top. Modular spindle. I'll just call it a top. Right, so it's going to change the name of that so I can get rid of it out of the way. Modular spindle top. There it is. Okay, modular spindle top. Let's just get rid of that. We don't need that. Right, so I can turn off that now. So I just want the bits we're going to be working on. Hey Jordan! Sup, how you doing, mate? Welcome to the live stream. What we're building tonight, Dave? We'll be building just doing some final adjustments to the switcher before I go on to the next project. Well, it's run parallel with this one. Yeah, let me just say hi to you. So I'll say hi to everyone in the chat. So right, there you go. I say log everyone in to say hello until I get to the stage where there's too many, but that'll never happen. So anyway, right, yeah. So I'm just doing a few mods to the small bits of the shaft that holds the contact for the switching. So that's what we're doing at the minute. Right, so what I'm going to do is, I forgot what I was going to do now. Yeah, so we'll lose that a minute. Can we do anything with this? Let's have a look. This is the bit that sits between the middle of it. I'm not sure if that can be made any thicker. One at a time. Yeah. If you've got a complicated problem, cut it down into simpler parts. Otherwise, you'll never be able to do anything with it. Right. I think it should have been okay. I might have come across. I pressed it there, and it snapped there. Now, they're only tiny things. These are. Let's have a look. They're only tiny things that get printed out. Now it's got all the weight. Obviously, if you're operating the knob, the top part has the stop in it, so you can only go against the stop. So you can't physically put pressure on this. But when it's held from the bottom, when it's on the stepper motor, the force comes from the other way. So it does have to transfer up the shaft to the top where the stop is. So this needs to be as strong as possible. So I might have to modify that somewhat. I don't know why one broke. I was trying to force at something and it snapped now. In reality, I shouldn't be able to snap that. It should be too hot. It should be flexible. So I don't know whether one of the earlier ones that didn't have 100% infill got mixed in. Anyway, yeah, one at a time. Right, so we'll leave that for a bit. Let's concentrate on the other one. So we'll hide that bit, which is the modular shaft spacer. Right, so we just want these two top bits at the minute. So I said I wanted that piece has to stay exactly where it is. So the top surface and the bottom surface can't change, but the two opposing faces can. But the contact has to stay in exactly the right position because we've optimized it spot on to be exactly like that when we put the feeds on. Hang on, let's just get rid of the right. So actually we'll need the stops and not the feed. Where's the feed? Yeah, turn that off. So, and we're upside down. Well, I've still got the ball bearings there. Anyway, I don't know why we've got the ball bearings. You have solved your relay contacts. Yeah, yes. Relay contact is great. It can actually hear the ball bearing click and the contact, I can hear both 2 clicks. There's one very millisecond delay between the two. So that ball bearing won't sit in, but then you can hit the side of this round, and it actually you can feel it. If I hold on to the SO239 and turn it, I can just feel this touch the top as it rides up onto it, and it got good continuity. It's a silver coated contact rivet onto a phosphor bronze piece. It's got the soldered earth strap going over to the feed connector, which is that green one, and it wraps around here as you turn. When you go to number 1, which is this one, it tightens up. When you get to number 7, it unwinds. Yeah. Anyway, let's get back to just altering this. I don't want to spend too long on it today. So my ball bearings are still in the way for some reason. What did I do with the ball? What did I call them? Right, so I've got motor spindle ball bearings. There they are. Right, so I'll get rid of them in a minute. So what I want to do is I've got to keep the bottom surface and the top surface in place and that contact. So I want that as it is, but I want this longer, so that should be easy enough to do. So if I measure this now, 1.417. So if I go into this and just raise this up by 1.417, and this one 1.417. Right, that should then bring that up to the top. You can't tell because it's still got the other one in place, so I'd have to then alter, not that one, this one would have to be brought down by that amount. Now this is only the cap. Yeah, this doesn't do a whole lot. It just passes the drive shaft through. It's more of it just holds the thing in place, so I think I can get away with that. So let's just bring that flush to the top here. Right, so we brought them down like that. I'm going to turn around upside down and zoom in. Right, so that I'll leave the lines there for a minute in case we've got too much going on. Right, let's bring the top back in. Some X-ray mode so I can see what is going on. Right, let's try to work out what's going on. So we've got we've got our bottom piece still holding the contact strip up. We've got our sides that actually go down to the bottom. Now we do need a bit of a gap. Oh, no, actually we'll leave it like that because it was designed like that. So that's good. What else do we need? It's difficult. Oh, I want to make this bigger ultimately. Can't really see a lot in X-ray mode. Let's just go at it again, back the other way around. I need to see it from so many different angles, it's crazy. So that's sort of sandwiching this thing in place. So the idea is you got it loose, you can solder your earth strap onto the back and you drop it in place here. You drop the contact in here and these little tangs hold your contact in place because that's how they are in the old relay when you've reclaimed it. That's just a representation of a solder tag, and they're tapered as well. Some of them are slightly tapered. The idea is you've got different contacts that you're going to reclaim from different relays. So the idea is to change that and that out depending on which one of those you're going to be using. Anyway, so these are a bit weak, so I need them bigger, so that's easy enough to do. Now we've only got the one to do. Now the other, the drive shaft, I don't know what do they call it? Spacer. This just goes straight through the two, like that. It drives straight through this one and this one. And if we quickly, you can see as it pops both on, and it sticks out the top, ready for the knob side of it. The top, what did I call it? The top pushes onto it, and it takes the ball bearing into there. There's enough room on that hollowed out bit for the bottom of the ball bearing, and that ball bearing then snaps into the lid. Then you've got your open and close stop, so antenna 1, antenna 7 stop. So while you're working off a stepper motor, you are having to transfer the whole of, hang on, where's the rest of it? Turned it off. Alright, so the bottom, yeah, you're having to transfer your stepper motor, fits in there with a sleeve, with that sleeve, and you're transferring, that locks your spacer or drive shaft, locks into the bottom one like that, it keys into there. So you've got two prongs there that are quite short, and then you've got your longer ones that go all the way through. Now the prongs on the spacer have a gap to let through the contact, because it goes along its length like that. So the contact, actually if you go X-ray you might be able to see better. So your contact is having to go through there, and it has to be this exact height, so it's through there. So the drive shaft, which is this bit here, if I just goes around the contact, there is a bit more gap there to it. Yeah, so that actually sits up a bit now. Actually it's that surface there. Yeah, so it doesn't touch this. Although if I wanted to make it shorter I probably could, but I have to hollow out this bit. Anyway, I'll leave it like that for now. Let's get back to adjusting this. Right, so we've got this bit, these two bits. So yeah, we said these were too small, so let's hide the sleeve and the spacer. Get back the right way up, or the wrong way up, because we're upside down at the minute. Right, so I need now to get rid of the lines. Do I need to get rid of the lines? Let's have a look. Yeah, so we've got that. We don't need this line anymore. So let's get rid of the lines. So hopefully we can get a few of these printed. This is probably, I don't know what the iteration of this contact holder is. It's probably getting quite high now. Different amount of versions of it. Right. So we've got that there. That's okay. Right, so that's all we need to do for that. We quite possibly could make this a bit thicker. Do we need it thicker? I don't think we do, because it's only just retaining the contact strip. So what I need to do now is make this wider. So how we do that, we're going to have yeah, but we did want to make it into a different shape, so a conical shape, if I remember right. Yeah, so we want this, so basically want this, if we do like a bit of a trial one here, so you want that. And then we wanted, so if we just go like that, then we'd have another circle in the middle, like this, something like this. This is, and then we want to bring that down. Is it even possible? Hang on. No, hang on, done it the wrong way. Let's just undo that. So if we put another one in the middle there, make it like that, then we grab hold of that. Can I bring that up or not yet? No, it's not part of the thing. Why not? Right. I forgot how to do it now. What happens if I bring that down? No. So you've got to give it a thickness first. So let's give it a thickness. Give it a thickness first. Right. And what I'm trying to do is, yeah. So I need to give that a bit of a size like that. And I grab the side of this. Or do I pull that up? Can't remember now. Let's try it. Oh, there we go. There we go. So you want something like that, like a conical. So when it winds up, the braid or the screen just can't really snag. So that needs to translate around here, really. So easier said than done, because we could actually make one and put it on the same height. Yeah, so we want the angle. So we could do this, and then I would have to take the inner bit and these cutouts. Right, so let's just get rid of that. Let's just backtrack a few things to get rid of that. Right, so we know what we need to do. And at the same time, it'll double up, it'll make it conical, and it'll make it stronger as well. It'll do the strength. Okay, so there's certain things we need off it. So best thing I can do is, yeah, now if we did that, we'd need substance. Yeah, so if I make a new one, so I need to call that, right, so I need to switch that one off. That's the contact holder. Contact holder, there it is. No. Where are we? Contact cover. There we go. Right, so we need to hide that while we're working on a new version of it. So I could do that. So the first thing I'll need to do is probably get rid of the contact for a minute. Contact holder, contact strip. So we need this block, sort of like a pedestal it sits on. Right, so what I need to make is something like this. So I need to measure that. Right, so it's 34 mil. We'll make it the same thickness. 1.5 mil. So 34 mil by 1.5. So if I just go something like, it's difficult to do. I need to start off somewhere. So if I say that's the space for it, it needs to be in 3D to get lower down. And I need to be away from there it is. Right, so I can just go to there, so that'll give me my base. So I've got my base, and we said 1.5 mil. I don't necessarily want it 1.5 mil, but we've got to start with something. So yeah, because it's going to be a cone shape, and it's it'll have its own strength. Right, so yeah. Oh, we can hide that other bit. Spindle top, get rid of that a minute. So we've got this extra bit of surface here. It doesn't necessarily need to be a lot, so let's just say it's 0.5 mil. 0.5 to start with. Then we need to put in the original width of the top bit, but it needs to be bigger. Does it need to be bigger if we're going to use conical? Because the conical will have strength anyway. So it probably doesn't need to be bigger. So if I do... hang on, that's not the one. What did I call it? I've lost it now. Hang on. Spacer. No, it's down here. Contact strip, ball bearings. Lost it. Contact cover. There we go. So that cover, if we measure that there, let's measure that between there and there. 16 mil. Let's make it the same. Make it the same. Let's just turn that off a minute. And the bottom. Why have we got the bottom back on? Turn the bottom off. Right, so we've got that there, and we want another. Yeah, we want one 16 mil, so 8 millimeter diameter. Right, so we've got that there, and now I don't know if we can pull. We might be able to pull this. Let's have a look. Can we pull that up? No, we can't pull that up, so we're going to have to go higher to start with. So if I cut that off, let's cut that off for now. We need this to be the original thickness of the other bit, which is the contact cover. Yeah, so we need to find the height of this. Let's get the height of this thing. Right, 4.695. So we, less half a mil. So we go into this. Right, so we need to go 4.695. Let's just go 4.695. Then we'll come down 0.5. That should bring us exactly level, with the top of the old one. Right, that's good. And then we need to disappear this one a minute. Put in the 16 mil. So 8 mil radius. Right, so we've got that there. We'll leave that where it is. So we grab this, and we've got to move this down. Let's move that down. Let's make sure it's going to come down. That's all the way down. We don't want it all the way. We want to give it. We don't want a fine edge. We want half a mil. So that's 4.695. Take off half a mil. Is 4.195. 4.195. There we go. So we've got this flying saucer thing, but it gives us our conical cut. And it maintains our original size for our holes that have got to be cut through. Now we've got to cut out. Use the. Hang on. That's the receptacle side. It's still got to maintain that, so we've got to combine the cover. Right, so the cover should fit in that conical as so far as around here, but this bit will be sticking out. But we've got to maintain that bit, so we're going to have to interact all that, copy that, and interact it with the bottom. So let's try and do that then. So let's go on to this. Right, so we'll copy all that. I'm going to copy it. Leave the other one intact. We're going to go into this bit. Oh, we're already into that bit anyway. We're going to paste it in place. Yeah. Now we've got to do something like Hang on, we don't want the bottom bit. That's right, so we need to turn that bottom bit off a minute. Spindle, what did I say it was? Holder. No. Spacer, what do I call it? Contact cover. No, it's none of them. Bottom. Sleeve, no. Can't find it now, where's it gone? Ball bearings, no. Contact holder, is that the one? Nope. Center feed. Spindle center feed, right, okay. It's a bit of weird naming, but that's the one. So we want rid of that. So we've got the two models together now in the same thing, space, but they're not integrated. So what I've got to do now is select it all and intersect the faces with the model. Now it's going to do some weird glitches because that's what it does, but in general it does interface it. Maybe. Yeah, it's got a few glitches. I can clean that up. Right, so we've got sort of what we're after. Let's have a look at it out of X-ray mode. Right, so similar. We've got the idea there, so that's it. Yeah, I like the idea of that. Yeah, that's fine. But we've got to get rid of a bit of stuff, so let's see if we can clean that up. Clean that up. So I think we've got to get rid of some stuff. Let's see what we can get rid of. There's a few glitches. Right, we'll just get rid of bit by bit. Can I get rid of that? Yeah. Okay, and some bits we can get rid of. Obviously we've got to get rid of, let's turn it over. We've lost a little piece going across there. Right, okay, we can get rid of that bit of a glitch and also that. Right, so we've mainly got what we wanted, but we need the other bit to fit into there. So this has got to be got rid of. No, there's something amiss there, so let's bring back this geometry. Right, so let's just get rid of that. Oops, what's going on? Why have I suddenly... Oh, that's the original one, is it? I need to turn off the original one. Contact cover needs to go off, yeah. Okay, let's just tidy this up a bit. We need that got rid of, that got rid of. Right, get rid of all these excess lines in a minute, so that's okay there. Right, then we want rid of this bit that's a manifold that needs to be got rid of. Right, we've got some more glitch going on. Yeah, that needs to be got rid of, so does that and that. Maybe that, yeah. And that. Possibly that. No, we want that back. Right, it's difficult, and we've got a bit of a glitch going on here. So, how can we get rid of that? So if we get rid of that, and then draw that back in either there, that's it. This one needs to go. And there's also something going on here. Right, let's just get rid of that and pencil that back in. Right, yeah, and this is not part of it either. That's got to go, so we can get rid of that. That's it. Because the other bit fits in there. Right, we've got something going on here, so we can. Let's just get rid of that, and draw in. Either draw that in there, which brings it back, and reverse the face. Okay. Right, we've got a bit of a glitch going on here. Same again. Alright, so slowly getting it back. Slowly getting back the idea. Right. Now we've got some extra lines there. Let's just give it a smooth over. And it'll get rid of some of the lines. Right, so we don't want the bottom, we don't want these lines anymore. Can I get rid of that? Nope, not quite. I can get rid of that though, and that. And that. Let's just get rid of that, because that is part of the bottom surface now. Right, it takes a bit of a time, but we'll end up with a nice template we can use for different kinds of contacts, with the conical to give us a bit of strength as well. Just get rid of any straggling bits. So yeah, we've got some extra bits in there we don't need. Okay, right, what's next? Slowly tidying up. Yeah, we've got some weird arse geometry within. That can come out. Oh, that's the old shape that's been superseded by the box side of it. And we've still got a few shapes. Right, let's go around the back and get rid of a bit. We'll end up with something we can print in a bit. Let's just get rid of a few bits of this. I've got some jagged bits. I think it's time to turn it. Oh, we've got a little bit going on down here. Let's turn that round the other way. Right, so if I get rid of that now, what's going to happen is all that surface going to go. Maybe. No, let's just get rid of that. Yeah, can I put that surface back? Yeah. Okay, so we've corrected that. What else? Oh, we've got extra. Yeah, that geometry is real. And is that real there? No, one of them's underneath. Can't tell. Hang on. Tell you what, let's put it in out of X-ray mode and have a look at it. Right, so we're doing okay. That looks like it shouldn't be there. Oops. I've got to be careful how much I get rid of at this stage. Right, and there's a bit that shouldn't be there. Right, so it looks like we've got to get rid of a few bits. I should be able to put the surface back again. Yeah, we might have to. There's a few bits to get rid of. It's a bit finicky. Yeah, because these are internal bits that no longer need to be there. Right. Still a few little bits here, look. We're getting there. Right, so that can go. We're getting there. So it's just a bit of a shortcut way of dealing with the irregular geometry of a cone. We still need to have lines down it, right? I think that needs to go. Can that go? Yep, that can go. Right, so we've got cone. Getting there. I think I need to hit save. Let's hit save. Right. Oh, my drinks run out. My drinks ran out. It's looking like a turret. Okay, so we should call it the contact turret, really. It is a turret. It's like a turret, isn't it? Right. Now, we've messed around here. Right, what's this at the side? Why have we ended up with that? Let's turn it round the other way. Oh no, we've got some more stuff to get rid of here. Internal manifolds or non-manifold edges, which we don't need at the minute there. Don't need any of that because it's going to be solid plastic. Right, there's a little bit left there by the looks of it. Right, let's get rid of that. Okay, what else? What else? Oh, there's a few scraps there, look at that. Right, so there's a few scraps there. Is there anything else? Oh yeah. There's these lines. Oh, that's part of the... Right, I see. So it's part of the base of the old geometry. Oh no, it does have to go there actually, yeah, that does have to go there. Yeah, because it's part of the solidness, yeah, so that's where you contact. No, it isn't. Sorry, no, it's not. We're looking at the wrong side. Oh, is that can go as well, I think. Let's look at it from the other side. Come at it from a different angle. Right, let's spin it round. Yeah, so we've still got the ability to drop our contact in. We've got some non-manifold edges which we need to put back. Now, I don't know if that's the real one or... Yeah, so we've lost a bit of our... Let's just say I could do with knowing which one it is. Let's bring back the sleeve, not the sleeve, the cover. So what is going on there? Not sure. Oh, yeah, I can't remember now. Right, let me just go into this one. So we didn't have any sides to it. We left it open. Yeah, we left it open. Okay, we could do that, I suppose. Left it open. We'll do the same with this one then. Right, I'll turn that off a minute. Let's leave it open. Keep it the same. So we just need to cut these off. And delete some of this stuff. Yeah, so keep it open the same. And the same over here. Yeah, because that's too thin to print and it ends up just turning to strands, so there's no point in doing a strand. Let me just turn these round. Right, so we've got them in white again. There's the two ends that need to be reversed. Okay, so we've got it like that. So our strip will just drop into there. And you've got enough room. Should have enough room on the back. Now we've lost our output. Yeah, we've lost our output here. So we need to carve in our output. So we've got a bit more to do. Right. Let's have a look. We don't need that line or that one. What else don't we need? Probably don't need these two lines either. I don't know what they're doing there. Anyway, so slowly we're getting back to what we want. Oh, these need to be reversed. Right, so we're getting there. Now our lid is missing. Right, okay, so we need to put the lid back on. Easiest way is just to like that. There we've got a problem here. These aren't interfacing with the model, so we're going to have to cut these off. Oh, if we did that we'll lose this track here. Right, I'll tell you what, we can try and interface them with the model, but we'll end up creating more anomalous geometry to get rid of. So probably the best way is to cut it, paste it in a different, and cut it and paste it back in. Right, so cut it, paste it in place, cut it, go into it and paste it in place. And we should better just delete them now. Yeah, that's it. So we've got our walls back again, sort of. Well, we have not actually got all our walls back. Sort of. We're going to have to put them back manually, I think. Right. We don't need this now. Don't need that. We've corrected our shape somewhat as well. Right, so something not quite right. Let's see if we can correct it this way. We've got our surface, so yeah, we just need to... We can either undo it and then push it through. I think we'll have to do that. So I'd have to temporarily... Right, let's do temporary fix. So temporary... Do this to fix them. Right, and then we can delete them. Delete these off here. Let's get rid of these because we need to push it through the surface to get our... We can do them all together. So if I delete them, come back up the top, and these are still there. Can I push them through? Let's have a look. Right, so I should be able to. So if I grab that, push that through to there. Has it done it? No. Why not? Hang on then. Undo. Right, so I'll try a different way. So I'll grab these. Oh. I'll tell you what I'm going to need to do is put them back temporary. We'll put them there. I'll just get rid of that. It's a pity that they're... Right. So what I need to do is... grab these. I think I've got to cut them out first. It's just a problem with SketchUp version I'm using, old version. So if I cut them out, paste them in place. Right, now there is some geometry still inside them. That's the problem. Yeah, I need to get rid of the geometry that's hiding in there. Right, let's get rid of this bit of geometry. Okay, so what have we got? Right, we've got another bit of hidden geometry. Oh no, that's the outside, that's okay. So we've got these two bits here that need, yeah, these need to go as well for the minute. Alright, okay. Let's have a look now. Right, okay, are we there? Sort of. Don't know. Let's have a look what's going on. Right, so that's the original one, yeah. That's the original one. I think we're going to have to put these back as well. And get rid of these, will it allow me? Yeah, get rid of them. We'll sort that out after. Right, so we've got this bit going on here. What have we got going on at the back? Oh, that's the old output. No, it's not. What is that? No, we don't need that, do we? Now let's get rid of that as well. Don't need that for the minute. Right, what have we got now going on? Let's have a look. So we got, yeah, something there. I think it's mainly clean now. Right, okay, so we come out of there. We need to grab these again. We've got to put them back into, so if we cut them, go into it, so we're on the surface, paste them in place. Don't know if this will allow us to do it. We'll try it. So if I push them down to that point there, that to that point there, will they be hollow? Yeah, okay, that's what we want. Apart from we've got too much geometry. Let's have a look now. Right, so what have we got now? We've got, should have our finished thing. I'll say it's a thing. Turret. We've got some extra geometry in there. Two lots of extra geometry. For why? I have no idea. Right, let's have a look around the other way in case we need it. Right, oh, they're on the outside. Right, yeah, it's the old stuff. Okay, we don't need it at the minute. Let's get rid of it then. I mean, when you come to print this tiny bit here, it normally leaves a bit of filament sticking out, so it's not really any good. Right, anyway, we've lost our, let's just put back some of this. Okay, so we've got that there. What about colours? Is that the back, or is that, no, that is the back. Oh no, that's not the back, that's the, so we need to, yes, it needs to be hollow anyway, but what we'll do is we'll put it back for now. Right, we'll get everything as it should be. Yeah, so the title today was a bit weird, wasn't it? The title, what was it? Is this the meaning of life? Just because we got to 42, isn't it? And then there's a reference to Galaxy Guide to the Hitchhiker, which is reversed. Don't know why. Never mind. Right, so we've got this here, but we need an output for the contact strip. So it's no good as it is. Right, contact strip, where are you? There's the contact cover. We don't need that now because we're replacing it. Right, so contact holder. That's the contact holder. Center feed. Oh, that's the center feed. Yeah, so that's the center feed. Our original one that contains the receptacle for the ball bearing, the arse end of the ball bearing to sit in. These should line up through there, yeah, to let the shaft go through, and then that should clamp the contact strip, which is not there anymore. Where's it gone? Clamps the contact strip in place. Yeah, and it provides a conical area for the earth strap to rotate around, all but this bit here. Now this could be made angled less, but we want a bit of meat on it to give it some strength. Yeah, so we're okay there. Right, so let's have a look what it looks like. Have we finished? Is that it? Maybe that's it. We now need to increase the width of this because we've got infill around there. So I need to zoom into it. I need to go into the model to see if there's any non-manifold edges. Right, I'm in the model now. Let's just have a quick look around. Don't think this. Oh yeah, we've got to cut the cutout so we can get to solder it. That's what we would do. So we've encased it. There's no way to get to the tab at the minute. Yeah, there's no actual way to get to it. So what we need to do is let's go up this way around. So we need to come out the arse end of it. And we've still got these bits here. Let's get rid of those bits there. Oh no, that isn't bits there. Hang on. Maybe it's bits there. Oh. What have I done? I seem to have... What have I got there? Oh, it's this bottom bit, isn't it? Why is it showing me that still if I'm already in that model? Am I showing the rest of the model? No. So why is it showing me? And that, oh, that's because it's not. I haven't made it into a component yet. That's why. So I need to select all that, and then deselect that and that, and make that into a new, or group it. Right. So that's it. Right. Okay. Yeah, I need to modify the output of it. So I should be able to now... Oh, it's not there, it's part of the bottom. Right, if that's part of the bottom, then we need to edit the bottom. Right, what is that? I see, it's part of the structure, so it's not really part of anything. Okay, that can stay as it is then. No, there's going to be a problem there, isn't there? They're sticking out into the plastic. Yeah, they're right flush against there. So I can't have that plastic overlapping the other plastic. Right. So let's have a look at that. Let's have a look. Ah, so yeah, there's a cutout. So I would have to have a cutout here to match that, and the rest of it is within. Yeah, the rest of it's within. So yeah, I have to reduce that by that amount, or cut it out. Yeah, actually, I'll tell you what, let's reduce it a lot more, because we don't need it to go all the way to the edge to hold this contact strip in place. suffice most of it to be held up. The rest can, yeah, so we can bring that in. We can bring that in. Let's do that now then. Alright, we don't actually need, this doesn't even have to be that exact there. It can just be, there can be a gap and push it down. So what I'll do is draw a line there and push this in. It can either go to there like that, which is probably okay, but it's going to be too thin. Too thin. So, right, we've got the angle, and it doesn't need the angle, but it'd be nice to have the angle. I don't know. Let's just not do too much. Right, let's just push that in. It's not going, is it? Why not? Why isn't that going? That's weird. Right, so push that how it is now. Right, so let's get rid of these. Right, so we've got a bit of yeah, we've got a bit of that going on. We'll leave it at, it's like difficult to work it out. So we've got a bit of plastic going on, but it's hardly going to be enough really there. We're constrained from the original size of the stuff, so that, yeah, so it can go less, can't it? We said it could go less. Let's do that then. Let's go a bit less. It's the top bit, the receptacle bit, that needs to be wide enough to take the copper strip, and the bottom bit just needs to press against it to keep it down. It doesn't have to be the exact size, but it's nice if it snaps together, so it holds it better. So we've got plenty of meat here to get rid of, but it's the back where, it's only the back where it, it's only the back where these, the drive shafts passes through. We need a bit more meat on it. So to make that stronger, I suppose, well, it doesn't really matter because it's grabbing it anyway, but I need a bit more plastic on it. So what we'll do is take the bottom bit and move it in a bit. Right, so we'll just move the bottom bit in a bit to give it a bit of strength. Yeah, it's a bit annoying. Right, okay. So how far do we want to go in? Let's say half of that. I'll just go half of that. We'll keep a bit of the zigzag on it. Right, and I can just push that down like that and like that, and then get rid of that and that and that, and that and that. So now we've got a bit more meat available to be printed, and it does narrow a bit there, but it doesn't matter, it's all one surface anyway. Right, so that'll do for that. Yeah, that's good for that. So far so good. Looks okay. Right, let's just have another look at it. Try and assemble it. So we've got the cover. So the cover goes over it. And we do need to keep the back thin, because it's got to take the actual physical copper strip here, so that's going to be thin there. Yeah, that's going to be thin. And we've got to bring that out the back end. So why is that so thin? It's only the same as what we had before, so yeah, we know it works. Oh, you've got a bit of meat there, that's okay. You've got some meat here, that's fine. So it's just extending it through. So you've already got the strength on it here, so that's fine. And all this is solid plastic anyway. So what we need to do now is push through where the contact strip comes out. So we need the contact strip, so let's come out one. So where this contact strip sits, we need a hole coming out. So if we don't need the whole thing. So what I need to do is measure that there. Between that, hang on, let's measure. I don't know how to measure that. Hang on, let's get it down to the surface. 1.1 mil. No, is that? Hang on, let's move the angle a bit. Got to measure that down to there. So we want equal amount of space from, say, let's go from there down 1 mil. 1.1 mil. Alright, undo that. 1.1 mil. So if I say we want to go 1.1 mil up, if I go across to the wall and then go up, I just want 1.1 mil, don't we? Hang on, I might need parallel projection for this. Oh, my arm's aching now. Where am I now? Right, let's get parallel projection. Right, we can do measurements now. Right. Oh, 3.669, is that right? Oh, 1.1. So from there, we want to go up 1.1. And we want a line across from there. It needs to be in level with that though. Right, hang on, I need to come at it from a different way. From the back. Yeah, so we need to come at it, we need to go into the bottom bit. Right, get to the bottom bit. Now we've no longer got our contact in there, so that's no good. Let's come back out of there. So we need our contact again. Hide, we need to hide this one. Center, I forget, holder. No. Center feed. I need to measure from here 1.1 mil. So if I temporarily if I go up here 1.1 mil and go across to there, right, that's the size of the hole we want cutting through. Now, are we in the model? No, we're not. So I need to get rid of that one. Cut that one out of there. Go into this and paste it in place. So we've got, that's the size of our cutout. We've already got a box there for the tab. That needs to go to the back base. I need to move that. Actually, I'll have to just draw it. Right, so then I can undo this, cut that out. So we now know we've got a box area which we need to push out the back of this thing. Okay, so right, so we need to push that back. Why have we got an inset? Oh, that's the that's for the solder tab. You need space for the any blob of solder to exist. So we need to push that out. So we can push that out, and it needs to go out to there probably. Right, so we've pushed it out and we've got this weird thing going on now. We've intersected with the cone. Let's come up the right way. We don't want the block sticking out like that. We just want a hole in the side of the cone. Let's come out of X-ray mode. So we want to, hang on. So we want to intersect that, and the bottom and the side with this. Now, is it going to corrupt it? Intersect the faces with the model or the selection? Right, let's have a look. Has it made any terrible thing of it? Back to X-ray to have a look. No, it's done it okay. Right, so all I need to do now is get rid of the excess. That should be easy enough to do, like this. So we've got an outline, and this is need to be got rid of. Right, and we also need to get rid of manifold edge now. Is that the last of it? Yeah, almost. Right, so we don't need this line now. No need for the line. Hang on. Let's try and it's just automatically got rid of it for us. That's good. Right, okay. So we just got some. Yeah. That's it. That's what we want. So we can get to the tab to solder it, or the braid. You solder it on beforehand. You slot it in. Should be enough room to slot it in at the back. And as you slot it in, oh, I'll tell you what. No, you don't slot it in. You solder your earth strap to the contact. So you solder it before you put it in. Then you feed the air strap through the hole, and as you feed it through the hole, you have the contact on an angle, feed it through, and then you drop it in over these tangs that holds it in place. And then you haven't got to melt your plastic because you've pre-soldered it. Okay, that's good. Right, so so far so good. Yeah, we've got space either side and up and down for the solder blob. Do we need all of this? Do we need all of that? We don't need all of that. It's close, but we don't need all of that. But we've got to be able to print this as well. Keep in mind it's got to be able to be printed. So hopefully this taper, it'll be printed flat like that, and then it'll go round and then step itself up for the print. Now we've got a hole that's got to be able to be printed. Hopefully it should be able to do that. I might have to print it with support and knock that out. Yeah, printed with support and brim. Support and brim. Yeah, so it's quite thin there, but underneath it's got the solidness there, so that's fine. It begs the question, can this be made narrower? Probably could, but I want to keep it like that, I think. Right, so there's that one. Right, okay, we'll keep it like that. Yeah. Keep it like that. Now, do we need to see, could that be brought out here? It probably could. But there is something else that fits in. Where's the other bit? So it's come out. Hang on. The cover. No, that's the old one. So, right, we said it was called the feed. Right, so we've got something going on with this feed. Let's have a look at this feed. Right, so we've done something with the feed now. We seem to have lost our holes for some reason. Is it because I put another one on it? Can I just delete that? Yeah. Okay, right. So we've got this bit sticking out the back here, which gives it a bit of strength as well. Now, how far does that stick into this thing? We'll have to have a look. Right, so we've got the feed that stops there. It gives you some space for solder blob. It goes all the way hollow down to there. But the block, what does the block do? I can't remember. The block stops there, yeah, so just, yeah, so this is in free space, but it's supported all the way across to there, yeah. Right, let's have a look. Oh, let's come out of this mode, can't see what's going on. So your block stops there and goes all the way up. And then it fits into there. Well, I think that's it. I think that's it. So everything else should have maintained its position. What's the size of this? 3 point. Yeah, that should fit in there. The braid should. Right, let's come out and have a look. Right, let's get the right way up. Which is the right way up? I don't know. That's the right way up. Right, let's put some stuff back in. Spacer. And the bottom. Yeah. So now you've got your conical thing. So when it winds, it can lean against it and guide it around the bottom a little bit, maybe. It's added some strength to it. And probably you could do a bit of an angle on that more, but I'm not that bothered. I should be alright. Alright, then you've got your knob at the top, which is your top down there. And then you've got your bearings. Where have I done with them? You can never find these bearings. There they are. Your ball bearings. Right. Okay, so it looks a bit more robust now. Yeah, we'll go with that, I think. So the only thing I've checked, the contact we haven't moved. It's still in exactly the same place. Can you get to the back to bring the feed out? Now it's the only problem is it's going to be sticking out of there, and it's got quite a sharp angle there. Does it matter? Probably not. Would it be better if it was less of an angle? Maybe. Well, we'll leave it like that. Yeah, we'll leave it like that. Right. Okay, so let's print out these two bits then while we're waiting. Right. Right, let's get these. So that's one bit to be printed out. So let's get this exported out of here. Let the drive spin up. There we go. Right, so modular shaft. What did we say this was anyway? I forgot what it was now. It's the contact cover. Bottom, what do I call it? Contact cover. No, it's now the contact holder, isn't it? That's the contact holder. And then we want the contact cover. Let's make sure it's okay. Export. Right, contact cover. There we go. Right, that's the only changes we need to print out. So we go into the Bamboo Studio now. Go back to this plate over here. There's the old one, the old 2 there that was a little bit thin. So that one is changed so we can get rid of it, so is that one. And these are copies of that one, so that's a copy of that one as well. The rest are just duplicates. Oh, that's a copy. That can go. What's that one? Oh, that's a copy. That can go. Right, so yeah. The rest are okay. Right, let's import those 2 into here. Right, so it's that and that one. Contact cover, contact holder. Right, so I need to just inch them across a bit. Put them the right way up. And this one, sorry, this one. See which way that wants to do it. Right, so okay, it's going to do it that way up. Why is it rotated like that, I wonder? Okay, so we'll undo that a minute and we'll rotate it ourselves along the blue 180. That's it. Right, so they're all lined up. Right, so let's just line it up. Oh, is it lined up? Yeah, it's lined up. Okay, we'll live with that then. We don't need that again at the minute, so I'll make that non-printable at the minute. Right, so we want to make it 100% infill. Let's give it 4 walls. Probably don't need the walls if it's 100%, but anyway. Now this thing, it's going to be quite heavy. Does it matter? I mean, yeah, let's just make it thick and heavy. Although, yeah, I don't know. Does it need it? No, does it need to be? That one's quite thin. This is thicker. Does it need to be 100%? Probably not 100%. We'll make that one fit 50%, but we'll give it 4 walls. 4 walls. Right, so we've got 50%, 100% on that one. And that's 50%. And these are so small, the walls will just make sure it prints the right stuff out. Hang on, where's the other tang? Yeah, it's there. Right, okay. Right, let's just slice the plate up. Right, let's put a brim on it, and it should have put some support material as well. Yeah, so it's deemed it didn't need support material there. Let's just have a look. So we're on plate 4. Let's have a look down at plate 4. So 100% and 50% inner and outer, and oh, no support. Didn't say it needed any. Do we think it needs support? Maybe, maybe not. Let's try it without support. Right, we're going to try it without support. We can have a look. Let's just close that down. Let's just come down here and see what's going on. Yeah, I think it'll be fine. Right, let's try it. Let's print the plate. And always the first one never turns out any good, so I need to get the temperature up and the inner temperature good. But we'll give it a go. It always scraps the first one, but I don't think it's going to take too long to print it. Yeah, I don't think it's going to take too long. Right, I can turn that on and it'll show us the picture. So my humidity's raising, I noticed. I might have to do a dehumidify these filaments at some point. It's raising up slightly, so yeah. Maybe it's the weather, changing the weather. That's going to take 19 minutes according to that. So I'll let that carry on. I need to keep an eye on it in case it doesn't stick. The first one never really sticks very good. I suppose I should go and clean it with a glasses wipe, give it a good quick scrub, but never mind. We'll see what happens. Right, so what have we got going on? Let's just reference the thumbnail, see what's going on. Oh, doesn't really tell you. Oh, last tweaks. Yes, a few tweaks. Right, okay. Okay, so that looks quite a nice little spindle now. Yeah, looks okay. So we need to create a new one of them, new one of them, and one of them for different contacts. But it's modular, so it fits onto the same thing. Right, so what have we got? Let's bring it all back together. What else? Bring it all back. All the way back, and let's put the lids on. Why not put the lids on as well? Lids and base, and then we want the chassis. Chassis, where are you, chassis? There. Okay, so you've got your chassis. So you're back to there. Now we were going to put some of these stuff on the bottom one. So we could do that as well, but probably do some of that in a minute. So anyone new watching and missed the first bit, I'll just go over the next project, which is in line with this project. Scaffold pole, or aluminium or scaffold pole on a bearing at the bottom, held off a bracket on the side of a building or up on the side of a house, with your standard galv bracket that you fasten, comes out. The top bar contains a bearing that's bolted to the side that goes around a 50mm shaft that holds a scaffold pole in place at the top. The bottom one has got a bearing with a receptacle for the shaft, the scaffold to fit in, and it's a rotatable bearing that's fastened to another bracket. So you've got two brackets, a pole bearing and a bearing to align the top. Now the second bar underneath there, or at the bottom, probably not want to put it down on the bottom, anywhere you want, you fasten on it your stepper motor, and we make a big planetary wheel belt driven pulley with the same teeth as this, but massive, to fit around whatever it needs to be gear ratio. So we've got a small one going to a big one. And I don't know if that's going to be, is that going to be geared up or down? I haven't quite worked it out. So we're going to have to work that bit out. But this, it hasn't got that much power, so we're going to have to do some tests. So this top teethed wheel fits in two parts around, it bolts together across around the diameter of the scaffold, and then as you tighten it up, the teeth alignments, they line up. So you put your belt around it, and then you can rotate your shaft around. It's all on bearings. All the weight is taken on the bearings. Let me just see what's going on here. Home in the tool head. Oh, it started printing. Right, so that's semi-good news because it started to print and it hasn't dragged this test print over here. So that's good news. Right, I'm getting a bit thirsty. I'll probably go for a break. Top up my drink. We can stay on for a bit longer. Yeah, we're an hour and 45 in. Now, we can either end it there or print these out. How long are they going to take? 12 minutes. Yeah, I'll tell you what. Let's just hold on another 12 minutes. Get this printed out, have a look at it, and see if it's going to do the trick. So that was one of the tweaks. So we've made the contact strip holder stronger, wider and deeper, so we've tweaked that bit up. We wanted to do we'll let that go on. So we wanted to do, if I come back out of here, this one. So we wanted this one, the bottom, to have some graphics on it. QR code. I don't even know how you'd go about putting a QR code on. You'd have to do it in blocks, so that's going to be... I'd have to turn a QR code, or we'll just have the name of the website, I don't know, channel, YouTube, Half Greek Geek, whatever, G7UIV. So we'll leave that sparse like that and have a bit of info. We need a version number and things like that. Maybe. Let's just have a look over here. Yeah, we're getting a bit tired, so I'll probably do that off screen another day. Yeah, getting a bit tired now. Right, have I got anything else? Oh, picked this up the other day. These are like 15 quid, I think, so it's 20 quid. There's an ESP32 with a display built in. I picked this up for only £4, brand new. So it was a bit of a bargain, but it's I've had this out, yeah. It's an ESP32 with, it's got an SD card holder, it's got a NeoPixel LED, and it's got USB-C. It's got joints for charging up. Hello, Andy. How you doing? Let's just say hello to Andy. Oops. Let's say hello to Andy. Yeah, doing alright. Yeah, not too bad. You okay? Yeah, we're doing alright. Oh, I don't know if you heard about the project. The next project that's going to run parallel with this one. You might like this one. I took a look at the price of a rotator. I thought, God, how expensive. Anyway, we seem to have a stepper motor, and we're rotating this. So what would be nice is if we could use the same web interface, the same stepper motor, the same controller and everything else to rotate a small pinion wheel off a bracket and a scaffold pole or aluminium, say 2 or 3 meters tall, that sits in a cup on a bearing that you attach to an aerial bracket that mounts on the side of your house. And the top bit has got a bearing that sits, you slot it through, it bolts on the side of another bracket, so you've got 2 brackets like that, 2 brackets like that. And we bolt something like this, or all contained within. We make our own I think it's going to be hard to spin, isn't it? If you go on a bicycle idea, so a bicycle, yeah, is the front cog on a bicycle? I can't remember. On a racer, is that bigger? Does that allow you to go easier up an hill? And as you go lower, I can't remember now. I know the back needs to be wider and the other one smaller, so it doesn't matter whichever ratio. I'm going to try and work it out, so we'll have to make the stepper motor spin, go around fast. Doesn't matter if it doesn't rotate it. We're going to make a rotator that uses the same web interface off your phone, the same thing. You just choose mode of operation and you say I'm rotating an antenna mast. So all the weight is taken on the bearing. I've already found the bearing. I was given one today. I was going to model it, but no rush. Hang on. Let's see if I can find it. I think they're on online. What was the name of it now? What was the name of Brundles? Right, yeah, FH Brundle. Right, so they do a bearing. I don't know the price of it. I don't think it's too expensive. Right, so let's search for bearing for a hinge. See if they, oh, here we go. Right, yeah, something like this. Oh, 38 quid, Jesus. Right, well that has got in it, has it got drawing? Yeah. PDF. Right, let's have a look at the PDF. Yeah, so it's got this like axle bearing in it. So you weld this down to something and you slot that over the top. And you weld a cup on it there that you slot your scaffold pole into. There's a seal. So you fill it full of grease, you seal it, you pop it on. Anyway, it does actually tell you the price. Maybe these prices aren't trade prices. Maybe they're better than that. We get a discount at work, but anyway, there's that one size. They do different size. 40mm. There's a 40mm. Oh, that's 1710. Well, that's a bit more reasonable. 40mm. So that can take the weight of the antenna. Yeah, so that's a bit more reasonable. Yeah, so you can weld a cup on it. You can slot your scaffold. Aluminium. I'd use aluminium. Just 40mm or 50mm aluminium. Weld your cup on top. It slots in. Whether you want to put a bolt or a pin through it or something, or even have it split with a clamp. So you have that. Then you have your hang on. Right, so the antenna brackets where I was talking about are these things. I've actually got some of these. So obviously you've got to clear the apex of your house. What's that doing? Right, so you've got, if it shows us a picture anytime soon. Right. Go away. Stop doxing me. So you got one of these. And you've got your bearing that you bolt onto the side and your shaft goes up. Instead of having a U-bolt, you have a bearing. Let's try and see if they've got a bearing at Brundles. Right, so I'll just say bearing. I think they've got bearings. Right, let's have a look at the bearings. Standard bearing. No, they haven't got them there, but I've seen them somewhere. Standard, I can't get it. It's called a shoulder bearing. No, I don't know what I'm talking about. But anyway, yeah, they're cast bearings and they'll just spin at different angles. Right, so you've got that. Anyway, 2 of them, and you've got to make a plate that fastens off here to hold your hold this or something like this. So it'll spin freely. You can spin it with your fingers. It's got to be able to spin easy. Then off here, your bearing that holds it up a bit. Then the down bit, we attach the stepper motor bit round the shaft, and it's all contained within a weatherproof plastic enclosure, and the drive belts within as well. So you've got plastic covers you can fasten over it, and then you go to your web interface as normal. And anyway, oh, what's going on there? That's all gone to wrong. See, that's gone wrong. Look, it's come unstuck from the bed. So there's no point in carrying on with that one. I told you, always the first one goes a bit crazy. Anyway, I'll print that out later. Yeah, I'll cancel that. Started doing it, so it's knocked it off and it's come adrift and it started printing in free space. Never mind. You can have a look at the... hang on. You can see what the price... 20p, but it hasn't quite finished it, so it didn't use all that. Right. Okay, I'm getting a bit tired now, so... oh God. Have a rest. It's getting warm in here as well. Blooming hell. Right. So anyway, that's the next idea. What do you reckon about the next idea, which is going to run parallel with this one? So the web interface. Let's just switch the web interface on. Hang on. Is that it? Yeah. Let's get the web interface up a minute. Right, here's your web interface. Right, so your web interface, when we log in, we're gonna, instead of having these buttons, we're gonna have a picture of this, picture of that on the web interface, and then when we go into the settings, we'll be able to have another tab down here. Call it mode of operation. I don't know if I've got anything like that. So you already got firmware updates and all sorts of stuff. We've got to get rid of some of this. It's based off my other stuff. So when it says reader type, you can choose. We'll have instead of having this, we'll have mode of operation, and you can choose whichever one. You know, you can choose antenna switcher or rotator. And then the picture over on the control side will change to either that or the degrees of rotation. And then you can have a sweep and a dwell time, whatever. Yeah, because you're running it on here. There's different opportunities to do with it later on, but I mean, you know, you can connect it up with your cat control. Read the signal strength and automatically tune it to where you want it to go to be. And the good thing is, if you actually, if we go on to just HF antenna rotator. Right, look at the price of them, and you've got this horrible looking box here. Yes, it'll probably work okay. You've got to buy this thing. I've seen people, I think DX Commander, Callum, I think he had some broken ones that are all seized up or something, I can't remember. Anyway, so basically you get rid of that and you do it off your browser. Forget about that. And if you've got your switcher already out in your garden, you've already got your 12 volts running to it. And all you need is your other 12 volt for your rotator, so you can just feed one lot of 12 volt out and feed both units. And stepper motor. You can have one of these. So you got one of these. Where is it? One for your stepper, your antenna switcher. Another one a little bit further down, connected to your rotator and all your electronics. And you can feed the 12 volts into one, back out, and into the other. So one 2-core cable for your 12 volts going out, and one feed cable. Yeah, so I mean, look at the price of some of these stuff. Look at that. Don't know. Anyway, so a stepper motor's cheap, and the bearings are like 20 quid. Say they're 20 quid. Bit of welding and whatever you need to do. Anyway, obviously experimental again. Experimental. So anyway, but it uses the same stepper motor and the same web interface. The same technology. So instead of designing something else, but we'd have to look at the gearing. Obviously, if you're going to turn a pole, doesn't matter how well you got it lubricated. If you're going to aluminium pole, whatever, steel pole, if it's balanced well, it'll just spin with. You'll have to get the gearing right, so we'd have to work out the gearing. I suppose ChatGPT could help me work out the gearing. Yeah, let's just go with that premise. We'll give it a bit of an idea. Hang on. Right, we'll tell it what we're going to do, and we'll see what it says. Right. Right. Here we go. So, NEMA 17 stepper motor on a let's say it's doesn't really matter, 5mm pulley wheel, driving a, let's say, 50mm round, 50mm diameter pole, let's say 3 meters long, 3 meters long, with wall mount brackets, and bottom hinge bearing, to take the weight, of the pole and antenna. The upper bearing fits around the shaft pole and acts as a support guide. Right, and I need to work out the gearing at the pole end. It will be driven by standard NEMA 17 drive belt. I think it's 2mm pitch. No, it's not, is it? I'll just say standard drive belt. What gearing diameter around the shaft, size could I expect. Probably going to say it won't do it, but you're basically designing a belt reduction from an EVA 17 stepper motor, large rotating mass. So the key is torque, not just diameter. Let's break it down in a practical way. What you're trying to achieve: motor pulley, typical GT2, yes. 16 to 20 teeth, yeah. Pole 50 meter, 3 meter long. Load pole plus antenna, wind load. This is a big unknown, yeah. You want slow, controlled rotation with enough torque. Reality check on an EMA 17 torque. Holding torque 40 to 60. Yeah, that's not much for a 3 meter pole, especially with wind. Well, if it's windy, we don't really care. Gear ratio you should target. For something like this, a good starting range is 5 to 1 bare minimum, 10 to 1 realistic, a 15 to 20 to 1 safer. What this means for pulley size: if your motor pulley is 20 teeth, then a 10 to 1 ratio, driven pulleys 127mm pitch diameter, so it will work if it's bigger, 15 to 1, 190mm, 20 to 1, which is ideal, 250mm. Okay, I can print up to 256mm, so that's good. Practical answer: what size should you expect for your setup? Expect a pulley at the pole of 150 to 250mm diameter. That's the realistic range of an EVA to handle. Inertia of 3 meter pole, antenna weight, some wind load. Important mechanical insight: this matters a lot. The torque at the pole, torque multiplies by ratio. That's much more usable. Critical design ones: wind load dominates everything. Even a small antenna can create huge torque on a 3 meter lever arm. If outdoors, you may actually need worm gear or gearbox, not just belt. Well, I don't really mind if the wind wants to drive it against itself, because you can force them when they're energized. You know, if the wind's going to blow it, I'll know. Right, belt drive matters. Okay for light loads. Better. GT3. Okay, we could go to a different size belt. Pulleys. Shaft mounting: you'll need large pulley fixed to pole. Upper bearing guide only, good. Bottom bearing takes axle load, very good design. Stepper limitations: lose torque at speed, can skip steps under load. Yeah, I know all about that. Keep rotation slow. Yeah, I don't care, slow is good. Consider closed loop stepper or gearbox if precision matters. No, it doesn't matter. Doesn't matter. More compact alternative, strong recommend inside. Instead of a huge pulley, use a 3 to 1 belt stage, 5 to 1 gearbox. This gives same torque, much smaller hardware. Right, okay. So it's not saying it's not feasible then. That's good. Right, anyway, I think that's got to be it. I've got to go and get me tea. I haven't had me tea yet. Got to rest for a bit. So, we've done what we wanted to do. We've done a few little changes. We spoke about the parallel project to go with this. I can't see anything that would stop me. It didn't say you need. I mean, I'm just going to start somewhere with it. If it's just a small 70 sems and 2 meter beam, so be it. On a smaller aluminium, anything's better than nothing. Anyway, right, I think that's got to be it. So anyway, thanks for joining in. I've got to go and do something else now. And so that was the disaster of oh, it's gone down, isn't it? Yes, that was disaster of that. I go and take that off and start again, give it a quick clean and start it again. and hopefully, yeah. So soon I'll be able to finish off all this stuff we've got going on here. All this stuff's waiting to be built up, and I need to go through all the other stuff, all this stuff here, and put all the new bits in it and finish it off, and then get that sent out, get yours sent out, Andy, as soon as I've swapped those bits off. So maybe tomorrow night I'll be in a position finished. Don't want to send you one out that's out of date. I want to make sure everything is in the best position. Anyway, right, that's going to be it for today. I'll say 73. Have a good one and catch you on the next one. Let me know in the comments, anyone, about if you see the video, what you think about antenna rotator off a web interface. Possibly we can stick an accelerometer on it that tracks with it. Don't know, that gets moved with it, rotated, and so you can actually track your direction. A little chip called accelerometer. They use them in drones and stuff. So anyway, there's all that. So that'll be it for today. Thanks for watching, and I'm out of here. Bye for now.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say, no good deed goes unpunished.